Hello dear students, today we will discuss about compound microscope. Compound microscope. Its principle is it is based on the principle that when a small object is placed just outside the focus of objective lens, its inverted real inverted and magnified image is formed on the other side of the lens, and this image acts as an object for eye lens. The eye lens is so adjusted that the final image is formed at least distance of distinct vision. Here we will draw diagram of compound microscope. Now we will draw principal axis. This is called principal axis. Suppose we have a small convex lens. Suppose that its focal length is f and it is represented by f of O, means focal length of objective, because this lens is objective toward the object. Now we will place an object AB and its image will be formed at this point. Now this ray of light starts from A and it will be joined to the other refracted ray at point A dash, and this point is B and this point will be B dash. Now this is the image for objective lens and this is the object for eyepiece. This is the object for eyepiece. Now we will draw objective which is larger than the eyepiece. Now this ray will pass from, this is the line parallel to the principal axis, and it will pass from the focal length of focal point of eyepiece. It will pass from this, and one line will pass from the center of curvature, and finally these two lines will be meet at this point, and here image is formed, that is a double dash b double dash. Now the mainly there are two angles, alpha and beta. Here we will draw a imaginary object AB, and it will subtend an angle of alpha. This is the angle made by the object at the center of eyepiece, and this is the angle beta, which is made by the final inverted large magnified image at the center of eyepiece, and this is the C, the center of objective, and C dash is the center of eyepiece. This is objective and this is eyepiece. Okay, now we know that this is the focus point of convex lens eyepiece. This is the focal length of objective, and it is represented by f of O. O means objective, and this is the focal length of eyepiece. Okay, now we will find the magnifying power of a microscope. Next step is our magnifying power of compound microscope, and it is represented by m is equal to beta divided by alpha. We know that it is defined as the ratio of the angle subtended on the eye by the final image of to the angle subtended on the eye by the object. This is the angle subtended by the image, and this is the angle subtended by the object, because this portion is equal to this portion, and this is our object, and this is also our object, and this is the angle alpha, which makes an angle theta on the principal axis. It is called principal axis. Okay, and m is equal to beta upon alpha, and we know that for small angles alpha and beta, we can write m is equal to tangent beta by tangent alpha, and tangent beta according to trigonometry is equal to perpendicular upon base. Therefore, now we will find the triangle in which angle beta is made, and this is the triangle in which angle beta is made, and according to this is perpendicular because it is the opposite side of angle beta. Perpendicular is a double dash b dash b dash divided by base. Base is the c dash b dash, which is called d. Similar tangent alpha, this will be this angle alpha is made by this. We can write this a b, and this is equal to ab divided by d, because this distance is same for upper and lower right angled triangle. Now it will be find that A double dash B double dash divided by AB, because D will be cancelled by D. It can also be written as, now we will multiply and divide it by A dash B dash A dash B dash, and it will be equal to A double dash B double dash divided by, now replace this AB and this A dash B dash with each other, A dash B dash into, here a proportion is A dash B dash divided by AB. We know that this is the magnification power of eyepiece and this is the magnification power of objective. Therefore, magnification power of compound microscope is equal to ME into MO. And MO is equal to, according to objective, MO is the magnification power of objective. For objective, image is A dash B dash divided by object AB, which is equal to CB dash for ME. MO CB dash divided by CB, because A dash B dash is equal to CB dash and AB is equal to CB. AB is equal to CB. But CB is nearly equal to minus FO and is equal to the length of the tube L. Therefore, we can write MO is equal to L by minus F of O. From here, CB dash is the length of tube and CB is equal to focal length of the objective. Okay. Also, for simple microscope of single lens, M of P is equal to 1 plus D upon F of E. Therefore, final magnification power will be equal to minus L divided by F of O, this term multiplied by this term, into 1 plus D upon F E. This is our magnifying power of compound microscope, which is the product of magnifying power of objective and magnifying power of eyepiece. This negative sign shows that final image is inverted with respect to the object. This minus sign shows that the final image, that A double dash B double dash, is inverted. Therefore, this sign indicates the inversion of a final image A double dash B dash. Thank you.